Welcome to the beginner video series for the GRE. This is the third video on probability. If you have not watched the first two parts, please go through it before continuing with this video. I want you to pause the screen and give this question a try. I hope you have done so. Now let's solve it together. There is a 20-sided die numbered from 1 to 20 and it's rolled once. What is the probability that you get either a multiple of 3 or an even number? What is the probability that it is either a multiple of 3 or an even number? So let's find the probability that it's a multiple of 3 first. Now how many multiples of 3 are there from 1 to 20? The first multiple of 3 is 3 itself. Then you have 6. Then you have 9, then 12, then 15, then 18. So these are the 6 multiples of 3. Probability is 6 upon 20 because 6 are our favorable numbers which are multiples of 3 and 20 are the total numbers. Or means addition. We have to find the probability that it is either a multiple of 3 or even. Or means addition. Now how many even numbers are there? There are 20 such numbers, total numbers. Out of 20, 10 will be even and 10 will be odd. So there are 10 even numbers out of 20 total numbers. Now we have counted some numbers twice. The numbers which are both multiples of 3 and even. Okay. 6, 12 and 18 are both multiples of 3 and even. They have been counted twice. So we have to subtract those numbers. What is the probability that a number is both a multiple of 3 and even? There are 3 numbers out of 20 numbers. Okay. And when you calculate, you get the answer as 13 upon 20. So 13 upon 20 is the probability that a number is a multiple of 3 or even. Now let's say event A is the probability of getting a multiple of 3 and event B is the probability of getting an even number. So probability of event A or B is equal to probability of A plus probability of B minus probability of A and B. Okay. We got it using this. It is the same as this. Probability of A or B is equal to probability of A plus P of B minus P of A and B. Now let's discuss about mutually exclusive and independent events. Two events are mutually exclusive when they cannot happen at the same time. Okay. For instance, you cannot get toss and head or tail or head on a single toss of a coin. Those two events are mutually exclusive. You cannot get head and tail at the same time. If events are mutually exclusive, then P of A and B is 0 because they cannot happen at the same time. P of A and B is 0. In that case, P of A or B becomes P of A plus P of B because this term is 0. P of A or B is equal to P of A plus P of B. The events are said to be independent when the occurrence of one event has no effect on the occurrence of the other. For instance, if let's say event A is getting an even number on the first roll of a dice and event B is getting an odd number on the second roll of a dice. Now the first roll has no bearing on the second roll. Those two events are independent. Events are independent when the occurrence of one event has no effect on the occurrence of the other. If events are independent, then P of A and B is equal to P of A times P of B. Very important, you have to take note of both these. For mutually exclusive, P of A and B is 0. For independent, P of A and B is equal to P of A times P of B. In this case, P of A or B will be P of A plus P of B minus P of A times P of B. Okay, P of A plus P of B minus P of A times P of B. Now let's solve one question based on this concept. I want you to pause the screen again and give this question a try. I hope you've done so. Now let's solve it together. We are given the probabilities of D, E and F. And we are told D and E are mutually exclusive. If D and E are mutually exclusive, then P of D and E will be equal to 0. We are also told E and F are independent. If E and F are independent, then P of E and F will be equal to P of E times P of F. We are asked what is the probability of D or E. P of D or E is equal to P of D, which is 0.23, plus P of E, which is 0.4, minus P of D and E, which is 0. So this is 0.63. P of E and F is this, but we are asked P of E or F. P of E or F is equal to P of E, which is 0.4, plus P of F, 0.85, minus P of E times P of F, because P of E and F is this. So P of E is 0.4, P of F is 0.85. If you find its value, you will get the answer as 0.91. And with this, we come to the conclusion of this video, and we have completed the probability series. I hope you liked it. I'll see you in some another one. Thank you.